Hello world. I've been trying to improve my skills with Bayesian inference, Bayesian statistics. So I thought I'd give you an example of simple formula that I've used to improve myself with Bayes, and an example that I've used to try and improve my knowledge of it, because just following along on an online tutorial isn't necessarily the best way to do it. Cool. So the simple formula that, well, first formula you learn to work out Bayesian inference allows you to work out the probability of an event occurring given that another event has occurred. So how you'd write that would be the probability of event A given event B. This here means given, so A given B. And the formula to determine that is the probability of B given A times probability of B over probability of A. Now, there's another formula as well that you can use to work out Bayesian inference, Bayes' law. And for that, you'd only need to work out the probability of A given B and the probability of not A given B. So you need less information to do that. So the first formula that you generally learn when you're looking at learning Bayesian inference is the formula that I've just written down here. So the example I gave to myself to try and work it out independently was Liverpool football matches, whether they won or not won a game, and whether Van Dijk, their best defender, played or whether he didn't play. So in the table you can see, I've got in the top left is the number of games that Liverpool won when Van Dijk was playing. Then to the right of that is the number of games Liverpool did not win. This squiggle here indicates not winning. Not winning when Van Dijk played was 6. And the total number of games they won overall was 30. Total number of games they played with Van Dijk was 30. This is all hypothetical data. I haven't. This isn't the real data for the year, but it's just an example to give myself to try and work out and better understand how to do Bayesian inference. So then you also see here the number of games that they didn't play with Van Dijk was 10. 4 of those they won, and 6 of those they did not win. And you can see the totals here in the final two, the final column and the final row, showing that they won a total of 28 games, didn't win a total of 12 games. They played a total of 30 games with Van Dijk and 10 games without Van Dijk, so 40 games in total either way. So for the example that we're giving here, probability of A is probability of A given B. So we're trying to work out the probability of Liverpool winning, so W, probability of winning given Van Dijk was playing in the game. So if we go into our formula that we've just written, how do we work that out? Okay, I'll start writing a bit smaller because I'm using a lot of the screen to do this. So let's think about it. First of all, we've got that curly line. So the probability, first of all, we need to write the probability of B given A, so of Van Dijk playing given they won, times by the probability of B, which is probability of Van Dijk playing, over the probability of winning. Okay, so let's work out those statistics then. I'm going to move over to the left-hand side of the screen for this. So first one, P, W, given probability of given Dijk equals, so the probability of Van Dijk playing given that they won. So let's work that one out. So the probability that Van Dijk played given that they won. Van Dijk played a total of 30 games, so it would be 24 divided into 30. This would be this bit here. Yep. Then you'd have the probability of Van Dijk playing. So probability of Van Dijk playing This probability of Van Dijk playing is oh, yeah. It's 24 over 40. Sorry. Probability that Van Dijk played 30 out of 40 games. So the probability that Van Dijk played is 30 over 40. Now we have next one, which is so we're trying to work out the probability of Liverpool winning. So the probability that Liverpool win is 28 over 40. So if you now try and work those out, you end up with equals calculator 24 divided into 30. So that equals 0.8 times 0.75 divided by 0.7. Okay, let's work that out. So it equals 0.8 times 0.7, 0.8 times 0.75, 0.6 divided by 0.7 equals 0.857 and some change. So that would mean that the probability that Liverpool will win if Van Dijk plays is 8.857 and some change. So there's an over 85% chance that Liverpool will win if Van Dijk plays the game. Now let's try and work out the opposite of that. What's the probability that Liverpool win if Van Dijk doesn't play the game? That way we can work out whether Liverpool have a better chance of winning if Van Dijk plays or if Van Dijk doesn't play. So let's just remove everything that we've written down so far, apart from the actual outcome that we got. We've already got this. I'll rewrite the 0.85 in the corner so that we know what we're aiming for. What's our number that we're considering? So it's 0.857. which incidentally is the same as 24 divided by 28, which is really this number here. So now let's work out the opposite. So we're trying to work out the probability. Now we're trying to work out the probability that Liverpool will win given that Van Dijk isn't playing. Okay, now that equals same as before. No, will be the probability of Van Dijk playing given that don't win. That's the same as probability of Van Dijk not playing given the win times win. Okay, so we can work out those the same as before. So probability of Van Dijk not playing so let's work this out. So probability of Van Dijk won't play given that Liverpool 1 is 4 divided by 4 divided by 28. Probability of Van Dijk doesn't play Van Dijk doesn't play. Doesn't play. So probability of Van Dijk not playing given a Liverpool win is 4 over 10. Times the probability that Van Dijk doesn't play is 10 over 40 over the probability that Liverpool win, which is 28 over 40. So we can work those out. 4 over 10 is 0.4. 10 over 4 is 0.25. Then 28 over is 0.7. So which equals, the maths, 0.4 times 0.4 times 0.25 equals 0.1. So we've got 0.1 times 0.7. 0.1 times divided by 0.7 equals 0.142. So the probability that Liverpool win, given Van Dijk is not playing, is about 14%, which isn't good. Not good at all. So Bailey is much better is when Van Dijk plays. Let's put that number in 142. And that should also be equal to the same as 4 divided by 28. 4 divided into 28 equals 0.142. Yeah, so really, when Van Dijk played, they've got a much higher percentage chance of winning. So really important that he plays in Liverpool games. Otherwise, their chances of winning go down quite a lot. Yeah, that was my quick introduction to the first sort of formula you do for Bayesian statistics. Hope it was useful. It was for me. Yeah, thank you very much.